Good morning, good afternoon, guys. It's IBDP Maths Academy greeting you once again. So today video, I'm going to do IB past paper questions on systems of equations or simultaneous questions, okay? Now, I hope you know how to solve simultaneous questions. Me, I'm going to do IB past paper questions and the skills that you need to know, okay? So this is the first question I'm going to do. Are you ready, guys? This was sent to me by one of my students. He asked me a help, then I decided let me make a video. So I'm going to do 2 questions of this nature, and I hope this video is going to help you. In case you have any question, just let me know, okay? So step 1, I have first equation here, I have second equation, this is the third equation, okay? Together, those are the 3 equations I have. Now, from these 3 equations, there is one equation where it will be easier to make the subject one of the variables. So as I can see, it's easier to make x the subject or z from equation 1. But when you check here, I have alpha z. So my choice is to make x the subject from equation 1. So what does that mean? It means x minus z is equal to 4 when I make x the subject. So x will be equal to 4 plus z. Altogether, now the equation I've got, I have to substitute it in equation 2 and equation 3. So let me start with equation 2. So it's going to be 2 bracket 4 plus z plus 2y plus z is equal to 14. Altogether, guys, I hope you understand that. Very good. Now, when I open the bracket, what does that mean? It will give me 8 plus 2z. Altogether there, plus 2z, then plus 2y plus z, 14. Okay? Now, the next step is correcting like terms. So I'll get 3z plus 2y equals to 14 minus 8 gives me 6. So it's 2y plus 3z equals to 6. Okay? This is my equation, which is very important. Okay? Pay attention to that. Now, go to the second equation. Was x plus 2y alpha z equals to beta. So I have, if the value of x is that, so I'll get 4 plus, let me use a different color so that maybe you don't get confused. So it's going to be, it was 4. 4 plus z, 4 plus z plus 2y, then plus alpha z equals to beta. Okay? Now, what am I going to get here? I'm going to have 2y. Let me check if I didn't make any mistake. I think so. I'm fine right now. Plus z plus alpha z equals to beta minus 4. Okay, I hope that one makes sense. Is that okay, guys? So here, this is another equation. So let me go with that. So I'm going to write this second equation first. So it's 2y. This time around, I can do elimination, guys, okay? Plus alpha z here equals to beta minus 4. Then what about here? 2y. For you to see what I'm doing here, 2y plus 3z then equals to 6, right? Now, when I subtract, because they are the same, so I'm going to have minus 2z plus alpha, because I did z minus 3z, I get negative. Okay, here equals to beta minus 10. Altogether at this point, I hope you understand that. Okay, like this here. Now, can I factorize the z? Because it's common. So I'll get negative 2 plus alpha equals to beta minus 10. Okay, fast forward. Now, I want to get z, so I'll divide both sides. So z will be equal to Z will be equal to beta minus 10 over alpha minus 2. Okay, this is 2, guys, not Z. Okay, that's the Z value. Now, wait a minute. This is why I want you to pay attention. They said now, find the values of alpha and beta where these are the set of integers for which the system of equation has the infinity solutions. Okay, now, if it has infinity solutions, that means both numerator and denominator will be equal to 0. Okay, now, because I want you to understand, there are 3 things which you need to know. There's infinite solutions, That's the first thing you have to know. There, your numerator and denominator should give you 0 over 0. Second case is when you have unique solution. Okay, for unique solution, it should be the denominator. This one, I'm just using an example. The denominator here should not be equal to 0. Okay, it should not give you 0. The denominator should not be 0. Okay, now that is infinite solution, unique solution, and no solution now. So for no solution, did you hear what I said? The denominator should not be equal to 0. For no solution, the denominator will be equal to 0. Did you hear what I said? So there are 3 key scenarios. Maybe when I'm doing this question, let me go. From the question itself, they said infinite solution. So to get infinite solution, the numerator and denominator you are going to be equal to 0. So which will give me 10 over 0. I mean, this one equal to 0. So beta will be equal to 10. Or alpha minus 2 will be equal to 0. Therefore, alpha will be equal to 2. That's the question itself. That is it, I'm done. I've got my mark. Now, what if the question was asking you unique solution? What if the question was asking you unique solution? Okay, 1 point of intersection, basically. That means unique solution, the denominator will not be equal to 0. So I'll just get the alpha minus 2 equal to 0. And therefore, by that time, alpha will be equal to 2. Now, for no solution, because those are the 3 scenarios they ask in IB exams. For no solution. So for no solution, that means the denominator should be equal to 0, which means alpha will be 2. Oh, sorry, unique solution, this one should not be equal to 0. Okay. Now, here, for no solution will be that. But not only that, we have to avoid having infinite solution. So the numerator should not be equal to 0. So that means I have to get beta minus 10 not equal to 0. Beta minus 10 not equal to 0. So in that scenario, beta should not equal to 10. So when you're revising systems of equations for IB exams, there are 3 things you need to know. Infinite solutions, unique solutions, and no solutions. Unique solutions, I mean having 1 point of intersection. Infinite solutions, that means they are meeting. The one line is on the top of the other. They are meeting at more than 1 point. So they are basically they are on the same line. I hope you have understood that. Fast forward, I want to do the second one. Are you ready? Okay, or I leave this one and then you try it and then tell me. Yeah, what did they say? I can give you this one and I get answers in the comments. Find the set of the values of A and B such that the plane has no point of intersection. That's what I was talking about. So this one, I'm not going to do it, but I'm assuming maybe you can have your answer. I say Z equals 2. Maybe, I'm just giving an example. I'm assuming maybe your answer is going to be B plus 7 over A plus 5, for instance. Now, for having no point of intersection, that means the denominator should not be equal to 0. It will be A plus 5, because any number of 0 does not exist, guys. So here 0, and therefore A, no, sorry, they said no point of intersection, so it should be equal to 0. So A should be equal to -5. Do you get that? This one, you don't need to mind about that. Is that okay, guys? I hope you have understood that. Thank you very much. IBDP Maths, we love mathematics, okay? I hope you have understood that one. Okay?